मैं डॉक्टर वी रामाराव साहब से इल्तिमास करता हूं कि सहनशील पर तशरीफ लाएं। सर, अस्सलाम वालेकुम। डॉक्टर वी रामाराव एक मुमताज मीडिया प्रोफेशनल हैं जो रेडियो, टेलीविजन, फिल्म, सैटेलाइट कम्युनिकेशन, मीडिया, ट्रेनिंग और फसलाती तालीम के मैदान में 55 साल से ज़्यादा कौमी और बैनुल-अक़वामी तजुर्बा रखते हैं। इन्होंने मुल्क के कई मुमताज़ अदारों में अहम ओहदों पर अपनी खिदमत अंजाम दी है, जिनमें ऑल इंडिया रेडियो एंड दूरदर्शन, FTI पुणे में प्रोफेसर की पोस्ट, ज्वाइंट डायरेक्टर इंजीनियरिंग IGNOU, चीफ एग्जीक्यूटिव ऑफिसर सैपनेट, फाउंडिंग डायरेक्टर मीडिया सेंटर मौलाना आज़ाद नेशनल उर्दू यूनिवर्सिटी हैदराबाद, चीफ टेक्नोलॉजी ऑफिसर SV वक्ती चैनल काबिल जिक्र है। आलमी सतह पर डॉक्टर रामाराव ने यूनेस्को, UNESCAP, UNDP, एशियन डेवलपमेंट बैंक और कॉमनवेल्थ ऑफ लर्निंग जैसे इदारों के लिए मीडिया कंसल्टेंट के तौर पर खिदमत अंजाम दी हैं, जहां इन्होंने तालीम के लिए इंफॉर्मेशन और कम्युनिकेशन टेक्नोलॉजी के इस्तेमाल पर खास तवज्जो मरकूज की है। एक बासलाहियत स्कॉलर के तौर पर डॉक्टर रामाराव ने 3 किताबें तहरीर की हैं, 40 से ज़ायद तहकीकी मज़ामीन शाये हो चुके हैं और इंदिरा गांधी ओपन यूनिवर्सिटी कोर्स के लिए आपने तालीमी मवाद भी तैयार किए हैं। आप मिनिस्ट्री ऑफ HRD, मिनिस्ट्री ऑफ साइंस एंड टेक्नोलॉजी, मिनिस्ट्री ऑफ INB, ISRO और डायरेक्टरेट ऑफ फिल्म फेस्टिवल जैसे वजारतों की तकनीकी कमेटी के रुकन भी रह चुके हैं। 2015 में डॉक्टर वी रामाराव ने इंटरनेशनल फिल्म फेस्टिवल इंडिया में जूरी मेंबर के फ़राइज़ भी अंजाम दिए हैं। सर बहुत अच्छा पेंटिंग भी करते हैं और फेसबुक के ऊपर सर के फॉलोअर्स भी होते हैं, तो मैं चाह रहा हूँ कि तालियों से आप सर का इस्तकबाल करें। नाउ दिस फ्लोर इज योर्स सर।
I think a very highly exaggerated introduction. So it has unfortunately raised your expectations. Unfortunately, I have to start with an apology because I have not even made any PPT or anything like that. So I start with a disadvantage because by comparison to the distinguished speakers who spoke in the forenoon, mine will fade into a kind of uninteresting affair. So anyway, having committed the mistake of not preparing for the lecture, let me make this disadvantage into an advantage by trying to convert the session into a kind of interactive session, an informal session, rather than a lecture. Because I find the audience comprises of not only the students, but actually practicing communication, community radio practitioners, and other veterans who may find the lecture on the equipment and the need for maintenance and things like that too elementary and too dispensable. I mean, it's not worth talking about these things. That kind of feeling may come. Anyway, let me carry on with my duty of having accepted the to talk on these matters. To begin with, at least assuming that the students may like to know these things, particularly the students who have a science background among you will know that these radio waves, X-rays, light, gamma rays, and the entire gamut of this radiation belongs to the family of electromagnetic waves, broadly speaking, electromagnetic waves, who have this common property of getting propagated in free space without the need for any medium. Of course, that is how we receive the light rays, etc., from sun and other distant objects. And so electromagnetic radiation is something which is universally spread. And we use, for For radio purposes, a part of that electromagnetic spectrum, as per international regulations, the electromagnetic spectrum, which is a natural resource given by the Almighty, you can say, and parts of that are used for various services. Radio, of course, uses a part of that radio electromagnetic spectrum, starting from the kilohertz and all that to megahertz. Television also uses part of the electromagnetic spectrum, and various other services use parts as regulated by the regulatory bodies, so that there is no clash between the services as far as the spectrum use is concerned. Unless the spectrum is properly apportioned among the services cannot be received properly because of mutual interference. If everybody starts operating in the same part of the spectrum, then nothing will be received because there will be interference. So every service has to operate in such a manner that it doesn't interfere with the neighboring services. It is almost like a road in which the traffic flows. Every car has to find its path on the road, and it should not exactly traverse the same straight line as the other car, because then you will collide and the traffic will not be able to move. It's almost like that. So in the case of the community radio, the VHF part of the spectrum is allocated, part of the VHF that too, for operating this community radio. And in the case of our MANUU radio, 90.0 megahertz, that is the frequency allocated. And the neighboring community, while allocating these frequencies, the authorities will take care that the neighboring community radio stations which are planned or which are already existing will not have the same frequency. Because if it is same, then although there is a geographical spacing between the stations, chances are that at the fringe of the service area, both these waves also will be received and the other stations' waves also will be received, and they will clash with each other, and ultimately the receiver will not be able to decipher which is what. That is interference. So care is taken while allocating the frequencies for the various community stations. In this case, 90.0 is the frequency allocated for our station. Incidentally, for community radio purposes, this range of frequencies, this VHF, as I told you, is allocated keeping in view the requirements of the service area and how to reach that service area properly and things like that. To make matters clear, let me say, when you think of medium wave and short wave kind of broadcasting, which now it is getting folded up more or less, but they were the standard mode of broadcasting till recently. And there, in that range of frequencies, the radio waves were traveling in a different mode, not as straight lines, but as far as the medium wave is concerned, the waves were crawling along the ground and get gradually attenuated. And that is the medium wave range of frequencies. And so the medium wave stations were operating in that mode through what is known as the terrestrial, the ground-based broadcasting. When you come to short wave, the waves have such property that they go skyward, encounter the ionosphere layers of the atmosphere, get reflected back onto the ground, and in that process, they will be able to reach much longer distances. So the advantage would be that your service area can be much larger. So the shortwave radio stations were reaching thousands of kilometers service area. Of course, the price that is paid in the process is the quality of shortwave broadcast will not be that good, when compared to the medium wave broadcast, because there are vagaries of ionosphere. The reflection will not be very consistent. Sometimes it is strong, sometimes it is less, and there will be fluctuations and so on. So the short wave broadcasting was beset with lesser quality of reception. And so it was not that popular as medium wave, but then the service area is much longer, so it has its advantage in terms of the service area. Now, unlike medium wave and short wave, the VHF range of frequencies, they have the property of rectilinear propagation. Rectilinear propagation means they travel in straight lines, very much like light. Light travels in straight lines. Like that, VHF also travels in straight lines. In other words, the transmitting antenna, the place from where you radiate your programs, that should be able to see the receiving antenna. The service area where the receivers are located, ideally speaking, the receiver should be able to see, like we see with the naked eye, the transmitting antenna. Then only the reception will be possible. That is because the rays travel in straight lines, and so any obstacle in between, such as a high-rise building or a hill or some other thing, will be able to block the waves, and so the service area cannot be catered to. That means the reception will not be available on the other side because the hill has blocked the waves. Although the receiver on the other side may be physically very near, maybe only a few kilometers, but still, because the obstacle is there, physical obstacle, it will be able to block the progress of the waves, and so this service area gets cut off. These factors are taken into account while planning for the community radio allotments. And as the speakers in the forenoon have told us, a community radio essentially is meant for the surrounding community. It is a very limited reach with a limited objective of communications with the local community, not very far. So the regulations have prescribed, or rather assumed, that a typical community radio station should be able to cater to a 5 to 10 kilometers radius service area. And that service area is assumed to be belonging to a certain cohesive, a homogeneous community. And so the community radio purpose will be served by restricting the reach of the community radio to a radius of 5 to 10 kilometers. And to reach that kind of a service area, and not much beyond that, the power of the radio station concerned is limited to 100 watts. You know, we have the FM radio stations now, both operated by All India Radio and the private operators. They are, in their case, the power restriction is 10 kilowatt. It could be 20 kilowatt also in some cases, but 10 kilowatt is the normally assumed power restriction. Whereas in our case, in the community radio case, the power restriction is a mere 100 watts. That is because in the community radio, we are expected to cater to a limited community of only 5 kilometers radius. Whereas the commercial FM radio stations, they are expected to cater to a much larger service area, the entire city, for example, say 60 kilometers to 70 kilometers radius. That is the essential difference. So, keeping in the view the fact that our community radio should not be able to radiate to the entire city, but restrict itself to only the community concerned, the power is deliberately restricted here to 100 watts. in practice, the radio stations therefore employ radio transmitters, the FM transmitters of 100 watts, that too as a combination of 50 watts plus 50 watts. As our engineers here will tell us, this 50 plus 50, this kind of a split is in practice followed for various engineering reasons, because in case of a failure of one section of the transmitter, the other section of the transmitter with 50 watts radius will be able to operate, and so you will be able to get a more reliable and trouble-free service without any breakdown. That is the reason why 50 plus 50 combination of the transmitter configuration is used in the case of our commercial, the community radio. And indeed, in the case of our community radio, which is going to come up, also uses 50 plus 50 configuration. So that helps continuity of service in case of any equipment trouble or breakdown. Well, to begin with, actually, one may like to know how exactly a community radio station in its hardware configuration, I mean, not the programming part of it, how it operates. For that, we need to understand that actually there is no fundamental difference between a community radio or the general broadcast radio, for that matter, as far as the hardware configuration or the equipment setup is concerned. It is just the same. Only the purpose of community radio is different, whereas the general broadcast radios, they have a different purpose, different service area, different target audience, etc. So hardware-wise, there are no fundamental differences. Nevertheless, let us understand how a broadcasting activity is conducted hardware-wise. For that, everything, we have to assume that everything starts with a studio. You know, there is a studio. There are radio studios. There are television studios. Television studios are meant for producing both the picture and sound, whereas a broadcast studio produces only the sound part of it. So a broadcast studio, a standard broadcast studio, just as you need that kind of a studio for general broadcasting, you need here also. Luckily, our IMC is happily placed in this respect, because they already have a professional studio setup of both radio and television ready on hand. And the same studio can be used for our upcoming activity of community radio. And what this studio does, essentially, it provides a controlled atmosphere, soundproof, so that the programs can be conducted inside the studio. Soundproof in the sense that the sounds produced in the studio will not leak outside, and outside sounds will not be able to percolate inside. So it is insulated from that acoustic point of view, and that is the obvious purpose of soundproofing a studio. There is another purpose also. There is a second purpose of acoustically treating a studio, and that is to make the sounds generated inside the studio quality-wise better. Technically, they should be very clear. The clarity of sound should be better, and there should be minimum resound, what the engineers like to call reverberation time, and so on. What happens is, if there is no acoustic treatment, even this room is acoustically treated, so we are able to get the sounds very clearly. When you speak, it will be clear. When I speak also, it will be clear. And there will be minimum resounding. Assuming that there is no acoustic treatment at all in a big room like this, there will be resounding. And so the clarity of sound will not be good. And in other words, technically speaking, the reverberation time will be much higher. So to control the reverberation time and to improve the quality of the sounds generated inside the studio, the acoustic treatment has to be done. So in our studio here, the acoustic treatment has taken care of these objectives. And I remember when we designed the acoustics of this studio, we designed it for talks. Again, engineers know the fact that reverberation of a studio is a tightly controlled one, in the sense that you have a different reverberation time for music studios, you have a different reverberation time for drama studios and talk studios, and there are variations like that, because music programs require a higher reverberation, a little amount of echo to make the sounds richer, whereas talk studio require minimum reverberation because clarity is important, not the richness. Drama studios are in between, where there is an amount of reverberation required at times, and clarity, more clarity in some cases. And so, uh, well, uh, maybe these kind of details may not be of interest to you, but incidentally, I'm mentioning that our studio is designed for talks because we are aiming for educational programs here where the talk dominates. Hardly there will be any chance for music to play there. So keeping that in view, it is designed for talks, which means a reverberation time of about 0.35 to 4.4 seconds. 0.3 to 0.4 seconds. That is the kind of reverberation it is aimed at the design stage. And luckily, even for community radio purposes, we do want that kind of a situation, because as the morning speakers told us very clearly, that what we need in a community radio is more and more talk, to quote Porala Saab. And Dr. Sreedher also was telling it is the actual live programs which are the lifeblood of the community radio, not music. Of course, music programs can be there, and even if music programs are built, suppose you are playing cassettes and all, it doesn't matter at all whether the studio is having X reverberation or Y reverberation. That doesn't matter at all. But when the sound gets generated there, it is the talk that we are aiming for. And already, luckily, our studio is designed excellently for the talks purposes, and that means it is tailor made for our community radio requirements even. And the studio will have gadgets. Like the most obvious gadget in the case of a studio, as you know, is a microphone. The microphone which converts human voices or other sounds into electrical signals, and thereafter the electrical signal is processed and converted into electromagnetic waves and all that. That is latter part of the story. So the microphone is the most important part of any radio studio, and so also is the case with the community radio. In practice, there will be multiple microphones to permit easier programming in the case of discussions and things like that. So wherever multiple participants are there in the program, you need conveniently more number of microphones. Of course, it's possible to handle things with single microphone, but professional quality will emerge if multiple microphones are used and they are controlled independently. And wherever these multiple microphones are used, you need other gadgetry also. One thing leads to another, so the complications will increase. If it is a single microphone situation, that single microphone will be connected to the transmitter, and transmitter will thereafter transmit the programs. That would have been the end of the story. But as you increase the complication of the setup, as you make it more sophisticated, multiple microphones, since multiple microphones are there, you need a gadget like mixing them. So you need mixer, and mixer means, again, there will be facilities inside the mixer to mix the various sources, and in that process noise has to be controlled, and so on and so forth. And after the mixer, it is by and large, there will be other gadgets like distribution amplifiers and all. Those are the engineer's domain. So I will not go into those kind of details. But the mixer is there to mix the various microphone sources or others. Say if you are playing a music from the playback deck, you need to connect to the mixer. And all those sources will be, whatever sound sources are there, you will that will pass through the mixer. The mixer will mix them, and the mixed output will be given to the transmitter, barring certain other details. It is the transmitter which does the job of converting these electrical signals which are coming out from the mixer or the microphone, as the case may be, into electromagnetic spectrum. And that frequency conversion, upgradation, whatever you call it, up frequency conversion, so on. So that through a cable, what they call coaxial cable, that will go to the antenna that will be kept outside. When it comes to antenna is the actual piece of equipment that converts these higher frequency waves into electromagnetic spectrum and radiates all through. And as I told you, since the frequencies that we are dealing in the electromagnetic spectrum are such that the VHF waves are having this rectilinear propagation, and there is a need for the transmitting antenna to seize the receiving antenna, it is necessary that the transmitting antenna should be kept as high as possible so that the obstacles on the way are effectively eliminated and you are able to see the end of the service area conveniently. That is where I have a little apprehension as far as our this MANUU radio is concerned, because fortunately and unfortunately, we have many high-rise buildings right in the neighborhood. And they are likely to form very formidable shadow zones. When it comes to the shadow zone formation, it is very important that the immediate neighborhood should be clear of those kind of obstacles. There can be obstacles somewhere farther on, but not in the immediate neighborhood. Imagine a candle and you have something right in front of it. The shadow zone formation will be much longer. If you have the same obstacle a little farther, the shadow zone formation will be less. So also, here also, we have the L&T towers and we have other high-rise buildings in this telecom, Nagar, and so on and so forth. Everywhere high-rises. And so, the 30-meter height that the regulations prescribe, so you can't go beyond that because the regulations prescribe only 30 meters for community radios. So here also, you have to follow that regulation. Had it been at least on the top of the building, some kind of a benefit of doubt could have been taken and you erect 30 meters from the building. Of course, even that is not allowed actually. It is from the ground, it is 30 meters. But you could have taken some benefit of doubt and put 30 meters above the building, and you could have been in a more comfortable position. Unfortunately, I am told that there were leakages and other practical problems of erecting the antenna on the top of the building. So we have to go to the ground level for erecting the tower. And so the tower height is going to be 33 meters, in fact. 36. Okay, there is some consolation. So the 36-meter tower on the top, at the very top of that tower, you have this antenna system erected. And therefore, the antenna will be located at that height, and so it will be able to see. Hopefully, it may be able to get over those shadow zones of the L&T towers and so on, and you will be able to have a comfortable reception in the expected service area. But that is a critical point. So actually, my uh, my appeal through this forum to the regulatory authorities, whoever that may be, the Ministry of INB, is to modify these regulations and be flexible so that they could have two different kinds of regulations as far as tower height is concerned. Urban areas, one kind of tower height. Rural areas, another kind of tower height. Rural areas, 30 meters fine. But urban areas, they have to rethink about this regulation of 30 meters, which in situations like us and in Bombay and all that, it may be even worse. So there is a crying need for the tower height to be increased, and the regulation should be able to permit that. So hopefully the revised guidelines, whenever they come, may take a review of this tower height. Otherwise, the service area will be affected adversely. As we were discussing a little while ago, the quality of reception in the given service area will depend exclusively on these two factors, these two variables. One is, of course, the tower height. More height, the better. Less height, greater chances of shadow zones and interruptions. And the second factor is the power of the transmitter. The power of the transmitter, if it is 100 watts, the calculations are within that 5 kilometers expected service area, it will be able to give good signal strength even at the edge of the service area. But if the power is more, the power at the edge of the service area will be comfortably higher, and the signal to noise ratio will improve, and the quality of signal will be much better. Though, of course, we understand the limitation. You can't go up to 10 kilowatt and all like the commercial stations are given, because their requirement is to reach 60 kilometers and 70 kilometers. There again, the regulator can play a more cooperative role by dividing the regulatory framework in such a manner that the urban areas are having some ceiling of transmitter power. The rural areas can have some other power. Maybe the existing 100 watts limitation will work very well for rural areas, but in urban areas is a bit doubtful. In fact, Pauralasa was telling in the morning in response to one of the queries that in their case also they were facing some problem, in spite of the fact that, of course, they observed the regulations and all. They have the required power, they have the required tower height, but still a neighboring transmitter was interfering with them. Why? Because of the fact that the edge of the service area is not getting catered well with the help of the existing regulations. Maybe the tower height may have to be raised, or the transmitter power may have to be raised, whatever it may be. It shows that the existing regulatory mechanism is falling short of the requirements. I hope these factors will be taken care of with more and more community radio stations coming up, and with more and more feedback reaching the powers at Delhi. The regulations are getting modified from time to time. Already there were revised regulations some time back. 2-3 times the regulations were revised, but not exactly in terms of the power or the tower height, but there are other factors. There were some changes, but strictly speaking, these two factors have to be addressed more seriously in future modifications of these regulations. Well, I do not know what can be told in a form like this as far as the equipment is concerned. There is one probably thought among the public that community radio being a kind of low profile kind of radio, serving only a limited community, very localized and so on, its a technical setup also has to be a kind of simplistic affair. I mean, that kind of a notion may be there, but it can't be. As far as the setup of the community radio is concerned, the quality of equipment and so on, of course, within the regulatory framework, has to be top quality. Because if you are having substandard equipment and substandard setup, the technical quality of your broadcast, the quality of reception, the quality of sound, and so on, will be far inferior to whatever is already going on in the general FM and general radio broadcasts, and nobody will listen to you. Already you have a disadvantage that your programming is not entertainment oriented. It is it has a social purpose. It is designed with a certain social philosophy and a certain social service in view. And so it is not entertainment oriented, not per se anyway. And so you have a disadvantage when it comes to competing with the general broadcasts of FM or All India Radio or whatever it is. In addition, if your technical quality is inferior, it's a certain death of your radio. And so as far as the technical quality is concerned, it has to be of broadcast quality. It has to be on par with the general broadcast equipment, whether the studio equipment or the transmitting system or whatever it is. It has to be of that quality. And therefore the costs, I think now the BESIL, the Broadcast Engineering Consultants India Limited, the public sector firm, which is into this field of helping people erect their community radios, helping them choose their equipment, and they will supply the equipment on a turnkey basis. They will do everything, right from obtaining the clearances, SACFA clearance, this and that, GOPA and so on, and also supplying the equipment, installing them, and also helping the end user of the management, the community radio management, to maintain their setup. Everything they will do. And I think they are charging about 22 lakhs, you said? 22 lakhs roughly for setting up a community radio station. Excluding the building. But this 22 lakhs includes not only supply of equipment and their installation, but also erecting the tower, installing the antenna system, and doing the necessary field survey and things of that kind. All that. It includes all the technical activities. While, of course, 22 lakhs is understandable, but even half of that amount also is enough to actually start a community radio station, because it depends on the extent of sophistication that you are aiming. Any community radio station has to start in a small way. Don't have too much ambition to begin with of running a 24/7 service with all the paraphernalia in place and so on. Not necessary. So it can start in a small way. Luckily though, in the case of our IMC, the setup is already there practically, except the antenna and transmitter. Everything is already there, and so they are well provided that way. As far as the setting up of the hardware system is concerned, IMC is on a different platform altogether. But a general service, a general institution, what I would say, any other educational institution or any other community service provider, if they want to establish a community radio station, even much lesser budget also will do, say 10 lakhs, because transmitter costs about 1 lakh. Tower system will be the more costly one, maybe another 2-3 lakhs, including the antenna, and the rest of the studio equipment, practically negligible cost, assuming that there is a room. It need not, for that matter, need not be acoustically treated, for that matter. So, in a very simple way, a radio station can start with as low a budget as 10 lakhs as a kind of one-time investment. And as far as the running expenditure is concerned, it also, it of course depends on the how many hours of transmission that you are aiming at, and the kind of voluntary services that you are able to loop in. As the morning speakers have repeatedly told us, it is very important that the community should be involved, not the so that your programming has that involvement of the community. It need not be by professionals. It should be rather by the participants of the community itself. And so, taking those factors in view, the running expenditure can be as low as, say, 20,000 rupees, maybe a ball point mark for the running expenditure. Even that can be probably reduced with the cooperation of the community. In the case of IMC, what I would suggest, although Pauralasa was telling their experience of involving the students in this activity was sometimes beset with problems. In IMC case, however, I would suggest that the student involvement should be aimed at primarily in the day-to-day running of the station, in producing programs, as well as in maintaining the setup. For maintaining the setup, of course, the technical staff of IMC will be there on hand, but it is essentially the programmer there, the man who is conducting the programs. Okay. Yes, I am given a signal that I am exceeding my limits. So let me respect the regulatory mechanism here. It's the student involvement that matters, and more student involvement, the better sustainability that the center is likely to have. In the case of IMC, it is likely the journalism and mass communication students can be roped in, and if the community radio operations and community radio running can be made a part of their curriculum, if it can be made a part of their curriculum, chances are that they will take better interest and they will work more devotedly into this activity and will bring up the center. I do not know if anything can be discussed in this. I would welcome rather any comments, any doubts.
Sir, of course, there are challenges, technical challenges.
Thank you.
But since we have an academic community here, we can evolve ourselves in terms of materials and the content wise. And since students here every year come and go, so we can develop in terms of their, academic curriculum. So I don't think there is, in terms of, materials or in terms of content, there is much challenge. We can overcome technical challenges or the radioactivity challenges through our contents, isn't it? What is your view in this regard?
Yes, content generation, as you said, will be no problem because it will be students and that will be involved. So we are not aiming for any professionally sterilized or perfect content. For example, we are not expecting any professional announcements with the perfect pronunciation and things like that. We are aiming rather for relevant content by the students and useful for their programs and tutorials and so on and so forth. So that's not a problem. But how that is, but then the technical, what you said, the technical.
Technical challenges are there.
Technical challenges and this are unrelated. Technical challenges in the sense that whether we can cater to the service area properly because of the high rises and all, those are beyond the purview of.
But this the target community of this radio is students on our campus, and we have so many departments. So in order to attract the attention of the students and the community for this target community of this radio, we can evolve ourselves in terms of content being provided through academics in academic term.
Yeah, that is true. That is true. And but that is only one aspect of the content. We are also catering to the entire community, and so educational programs should not be viewed as the only stuff that this community radio handles. Is one segment of the community radio is educational programs meant for the MANUU students. Secondly, we should have other kinds of programs also meant for the broader community. And when it comes to that kind of that aspect, the broader community has to be involved, and programs have to be made with their help and their participation. All those things have
It
to
was
be there.
brought that community radio has its limitations, restrictions. It has to work on within a certain area.
Yeah.
particularly.
Mhm.
So in this perspective, we have a target in order to evolve ourselves academically and bring to students more and more themes and contents that is beneficial for them in various academically, ethically, as well as to develop their civic senses. These things can be brought.
Yeah. I take your point. Yes, very good. In fact, the regulatory policy framework also suggests, while actually in the very beginning, when this community radio activity was approved, and when the policy guidelines were framed in the very beginning by the ministry, actually educational institutions were not included. They were brought in a little later. Educational institutions also are brought into the framework of community radio. But initially, it was the community which was kept in view, and it was meant to serve the community in all its variety, to address their needs and for their self help and self improvement and so on and so forth. But then educational institutions were also included at a later stage, primarily because the educational institutions will be able to serve their mandate better by serving the surrounding community. Actually, an educational institution has an obligation to serve the community, and that objective can be better addressed by having this community radio. That may be the objective. And secondly, a community radio can be set up by an educational institutions more easily because of the availability of their infrastructure already, land and other resources. That may be another advantage. So what I am at pains to tell is, community radio essentially is not meant for education. Education is part of it, and all the more so because an educational institution is starting the community radio. Naturally, the educational programs will take a lion's share of the total quantum of programming. Doesn't mean entirely. We should not forget that community radio is not educational radio per se, but for the community at large. So that aspect has to be served. Then only we'll be able to serve the spirit of the community.
That aspect may be included. I mean, serving the surrounding community also.
Yeah.
And for this purpose, we have Department of Social Sciences, Department of Social Work, and Public Administration.
Exactly.
In order to, compare the current situation and requirements of the community, we can evolve this.
Exactly. In fact, community radio can be an experimental platform for those students, journalism and mass communication students, social service, social sciences students, and social work and all that.
Hello, sir. I am Syed Mudawar from School of Mass Communication and Journalism. I'm a research scholar. So my question is regarding, we have a theory in media called uses and gratifications theory. And according to it, the subscriber or the listener or somebody who is your viewer is the actual boss who chooses what to see or what to consume. In the challenging times of social media, wherein everything is just a click away from you, how do you see the future of community radio? And if we want to strengthen the community voices, wherein we are choosing radio as a medium, which is primarily an audio medium, don't you think that in the future, community radio needs to evolve and adapt to the tools and techniques of social media and internet operations as well, so that it can have that prominent educative role in the society and can keep the society together in the future? Technically, do you see the possibility of that happening, or are we running late in that case?
A very intelligent question, I would say. Actually, although we are committed to community radio, rather we have our personal stake in community radio, in the sense that we are in this profession, so we want to continue as broadcasters, and so we want to support community radio. Actually, at the same time, we have to be realistic, and we have to understand the fact that with changing times and the changing technological scenario, the emergence of internet and so on, radical changes have taken place on the media front. And radio, whether we like it or not, radio broadcasting is losing ground. In fact, All India Radio, despite government support and all that, it is folding up. Television has folded up because the entire terrestrial broadcasting, as far as television side, is officially closed down. The entire LPT network, the entire HPT network, as far as terrestrial is concerned, completely closed down. Only satellite is remaining. And that also will undergo a lot of changes in the near future. So we have to admit this reality of radical changes taking place on the broadcast front, whether we like it or not. And that applies to community radio also. Community radio, now it is surviving in the form of an FM radio. But FM radio itself, no takers. In fact, the third, as Sreedher was putting it, the third auction that is being announced for FM radio stations, no takers. So that is the situation. That means the demand and preferences of audiences for radio as a medium itself is unfortunately is receding into the background. That doesn't, however, mean that the communication system itself, there is no need. The communities need communication system that may not necessarily be in the form of on-air radio. What we mean by community radio now is on-air, the FM. That may not live, but it will live in some other fashion, maybe through internet or through some other technology which may come in future. But the community radio in that new incarnation will survive. And so essentially, that has to be kept in view. Technologies may change. On-air technology may no longer be in vogue hereafter, and we may still call it community radio, but it will be in some different form, you see. Yeah.
थैंक यू सर. थैंक यू. एक जोरदार तालियां सर के लिए. आपने बहुत अच्छा थॉट प्रोवोकिंग स्पीच दिया. मैं उम्मीद करता हूं कि सभी लोगों को बड़ा अच्छा लगा होगा और बहुत सारी मालूमात मिली होगी. और अगला इस लेक्चर हमारा है ऑनलाइन. ये ऑनलाइन जुड़ चुके हैं.